Okay, we're going to talk about modding the valve on Crosman 13XX or 22XX model air pistols. So I have a valve here for a 1377, which I have dismantled in front of me. And I've already done most of the mods. So I'm going to kind of show you what I did, explain how I did it, talk a little bit about that. There's probably total about a half dozen different mods you can do. I've done 4 here. So the first one that you're going to want to do is take your Dremel tool. You'll want to actually have your cutting disc on there instead of that sanding bit. And you're going to cut the rings on the valve off. So this is the piece that came off. Generally it's like that. You're going to cut it about halfway and then just kind of sand and smooth out the edge. And that little piece will come off. Now that piece, if you were to measure how much space that takes up, you're going to get that much more compressed air volume inside your valve. So it's really a volume game that you're playing here, because the idea is that the more space inside your valve, the more air it can hold, and then the harder you hit that valve with the hammer, more of that air will come out. So this means that you can over pump, store more air, and then release more air. And there's things that you have to do in order to accommodate all of that. So for instance, if you want to over pump, generally you're going to need a steel breech like this to handle the pressures. You're going to need a flat top piston. You're probably going to need a solid roll pin like this one. You're going to have to reinforce the gun so that it can handle additional pumping and the stress that comes with that. So it's not just a matter of adding more volume inside your valve. There's other things you have to do to capitalize on that. So that's the first thing you can do. Then once you've cut that off, the area inside there represents, like I said, the amount of air volume you have. So you can take a bit like this, it's your Dremel, and it's tapered, or it's kind of conical, so it will go in at first. Now before I did this, it didn't fit in there, it only fit to about there. So I've got it all the way to here. You just keep working that in, keep working that in. And it's spinning around really fast, taking out material. And maybe you can see this, you'll see a lip of lighter gray, silver, compared to the dark inner gray, and that is where the material was removed. Now that's not removing a whole lot. There's other bits and things that you can do. I don't have a lot of machining equipment for that, but you can actually take that halfway down all the way to about here up and thin all that out. Now you got to be careful, you don't want it too thin, you don't want to compromise the valve. But I mean, you're going for cubic millimeters here of additional space. So it's not a lot, but it's something. And what that actually translates to in the amount of air that gets released, in addition to what it would normally have, it's probably not a whole lot. But the whole point is to maximize everything as best you can here. So those are 2 mods you can do to increase the amount of space in here. Another thing you can do, you can go to the other side of the valve. Now it's got threads that are tapped all the way down, because normally it's got longer threads here, but you've cut those off, so you don't need the threads all the way down. So you could take another bit Probably not this one. This one's kind of chewed up. You don't want to damage the bottom on the inside because that needs to be flush. So you'd probably want to drop something down in there like a little washer to protect it. And then you could take a bit, go down in there, and just hollow out this inside. And this is actually the opposite of what you did to the other part of the valve. So instead of going from here up, you want to go from here back and just hollow out the inside there. Because remember, you need those threads intact here because those meet up with these. So you can hollow out all that space, all that material, you get a little extra there. I'm not really going to do that. I don't think it matters too much, especially when you don't have the right equipment for it, which I really don't. So I'm just going to not do that one in this case. But those are 3 things you can do to actually remove metal material from the valve itself to give yourself more volume. The next thing you can do is to your valve stem. And you can see right here, I've taken away material and just thinned it out. You can actually get that thinner if you want. I don't want my stem to be compromised by being too thin. So I just took a little bit of material off. It looks almost insignificant, but it's definitely thinner in the middle than it is the rest of the way. Now this stem drops down in this part of the valve. Okay? And the spring goes on like that. Okay, there's the port opening. That is actually what lets the air into the barrel. There's a port valve that sits up there and actually attaches to the barrel. So air has to go from the valve and rush up through this into the barrel as it escapes the valve. And that's what gives you your air power. So that stem's inside there. But basically when it's inside it looks like this. It's sitting like that. The hammer hits it and it pushes it forward like that. Something like that. Okay, so when it does that, air is rushing past that stem. And it actually would like that stem to not even be there because it's just trying to get through that hole because it's pressurized air going towards less pressure. So it's got to move around that stem. So that's why you thin it as much as possible because you give it more space to get around the stem. And again, these are equating to minuscule amounts of efficiency, but it is better than not doing that. So you take, I use this bit at first because it's already got a little groove there, and just spun this, just chewed out material, and then once I got that groove going, then I took this and just smoothed it back and forth. You'll also want some compressed air and just blow in there and blow all the shavings out. Make sure to wear eye protection, probably a mask. But you want to make sure that the particles of metal aren't in there when you reassemble. So that's something you can do to your valve stem to allow air to flow more freely. There's actually another one that I forgot, which isn't really about increasing the volume, but it has to do more with airflow. So what you'll do is you'll take a bit. You can do a drill. I actually have a diamond bit that's meant for engraving. Okay, so the air comes, it basically goes horizontal and then goes straight vertical. So that's 90-degree angle that the air is traveling. That's not the most efficient way for air to travel. Ideally, it would want to travel at a 45-degree angle to accomplish that turn. So normally this would go in straight like that. But what you can do is take your drill bit, and this is a precision type thing, without disturbing the circumference of that top opening, meaning you're not taking out any material around the edge at all. You're actually taking material out from the inside of the chamber on this side right here. So you go in at an angle and you're just eating away the inside and creating an angle. So you're going in at an angle like that. Being careful not to press down too hard, taking out any material. I did slightly already, but it's not a big deal. But you want to avoid that. So you just angle all that material out. That will give you a little more volume as well, but it's mainly allowing that air to flow more freely around the stem and come up through that hole so that you can dump all the air from your valve each shot. So that's another airflow mod to the valve. The last one I'm going to talk about here is to the valve spring itself. And I'll just talk a little bit about how that works. So the idea of the valve spring is to allow this valve to open and close. And we'll just assemble real quick here. Okay. So it goes in like that. And then the hammer, which is this, comes down, has a spring behind it, smashes into the valve stem, and like I said, it pushes that tapered part near that hole, lets open the valve so that all that air that's being stored in this part rushes through and around and up into the barrel. Okay. So with your stock spring, valve spring, this is going to be real hard. There's a lot of pressure there. Actually more pressure than you need. So there's two ways to deal with that. You can get a heavier hammer spring and hit it harder, which will cause the valve to open further and stay open longer, or at least open up further, which will give it more of a chance for all that air that you've compressed to escape. The problem with that is the hammer spring tension directly correlates in most cases to your trigger pull, the weight of your trigger pull, because the sear is bound to the hammer, and the more pressure behind that hammer, the more pressure on the sear, which then translates to tension in your trigger pull. So you might end up with a really heavy trigger pull if you go with a heavy hammer. And then beyond that, there's something called mushrooming that can happen, which is when your hammer hits the end of this valve stem and it causes it to flatten out and deform. And that's not ideal, so it should still function, but it is not optimal, so you want to avoid that. So what you can do, I actually modify, this is the stock valve spring. I believe I may have replaced it a long time ago, but it's, you can tell it's thicker gauge than this one. And I cut a link off of it, about a full coil, stretched it out. So what that does when you stretch it is it makes the spring not as strong. And in this case, you want the spring to be lighter or weaker. So that's something you can do for that. But I went ahead and just got a new spring, which is a little bit longer, but it's a lot thinner. So longer would generally mean that there's more tension on it. But you can see that it easily compresses down to the size of the stock spring. And then if you push them both, you can tell that the one on the right has a lot less strength than the one on the left, which means it's weaker. So I'm just replacing this spring with that one. So what that'll do then is give me a really light pressure here on the stem, so that I don't have to use a heavy hammer spring. I can use the regular hammer spring, keep my light trigger pull, but it effectively makes the hammer more powerful compared to this, and will allow that valve to stay open. So I can then overpump, store more compressed air, and then critically release all of that compressed air, because I have a much lighter valve spring, and allow that valve to stay open longer when I pull the trigger. So that's kind of the basics of valve modding. One thing I'll do is I'll take some graphite grease, or I'm sorry, it'd be Loctite, the blue stuff, and just put it around the threads here, so I can ensure that that gets a good seal. It's got an O-ring on there, but the fact that you did remove some of those threads, you want to make sure that seals up good. So that should generally do it. And then you'll have your porthole here, and then exact 180 degrees below the other hole, which allows the trigger guard or trigger frame screw to come up through the tube and connect there. This is the valve for pneumatic pump Crosman pistols. However, CO2 valves function pretty much the same. The only difference is this has a flat front, which allows the piston to come here and compress air through the tube like that, whereas CO2 valves will have a seal and a needle, basically, or it's really a stem or a pin that's sharp, and the CO2 cartridge will kind of fit like this against the front of it. So instead of compressed air, you have CO2 air, but the actual functioning of the valve is still the same. From that part onward, it stores the air from the CO2. Valve opens with the hammer, releases air, and then more CO2 fills in. So that being said, all of these mods you can do to the 2240, 2250 valves as well, because the same thing holds true. You're just giving yourself more airspace, air volume inside the valve, and creating better airflow, as well as lightening the tension on the valve spring to allow that valve to stay open longer and release more air. So that is the basics of Crosman air pistol valve modding. Hope you enjoyed the video. Make sure to like, comment, subscribe, and thanks for watching.